So inverse or indirect proportion, I will use both of them, is when things don't have direct proportion. So one's going to increase and one's going to decrease. So as one of our variables gets bigger, the other one reduces. So an example could be, the more people who win the lottery, the smaller the prize fund gets, so each person gets less. Remember, one person wins it, you get a lot of money. Two people get it, your money halves, and so on. That's called inverse or indirect proportion. Other examples could be the number of people building a house, the time it takes. If we put in loads more men to help build the house, what should that do to the time? Does it make the time longer or shorter? It makes the time shorter. So these are all examples of inverse proportion. We can also bring it into speed, distance and time. If we up our speed, what happens to the time of our journey? As you drive faster, the time of your journey gets smaller. So again, inverse proportion.
Hi, I'm Ms McTaggart and this is a video on inverse proportion. Just so he heads up, if you're watching this video, hopefully you've already learned how to do what's called direct proportion beforehand. Now, examples of things that have got inverse proportion. This is when, as if you increase one item, the other decreases. So, for example, if you run faster, the time it takes you to do the journey is less. If you have to share your food among more people, you have less food per person. If you have more people coming to help you paint a house, it should take you less time. Things like that. So let's get into some examples.
So my first example, it takes 4 men 20 hours to build a wall. It must be a very big wall. How long will it take 5 men? Okay, so this is something that maybe construction workers need to be aware of. The manager will try and decide what's the best way, how many should they send out to the job, something like this, to predict where their staff are going to be the next day, etc. So 4 men take 20 hours to build a wall. That's the first thing I'm going to write down. So I'm going to say 4 men take 20 hours. I'm going to work out how long it takes 1 man and then how long it takes 5 men. Now, this is where your common sense comes in. We see a lot of mistakes with these questions. If you've done direct proportion would tell you, oh, you divide by both sides by 4. But we don't here. Let's use our common sense. Clearly, here I'm dividing by 4. Do you see that? 4 divided by 4 is 1. But if there's 4 people doing the job and 3 of them disappear and 1 person's left on their own, what is going to happen to the time it takes them? Is it going to take them longer or shorter? Now, common sense tells you, well, it's going to take them longer on their own. So we're not dividing by 4 here, we're timesing by 4. Their workload has quadrupled. So the time has times by 4. So it's going to take that one wee man on his own 80 hours to build that wall. Now, on the left-hand side, I am then multiplying the number of men by 5. That doesn't mean I multiply the time by 5 because 5 men are now going to come and share the workload. So the time should be reduced. So we do divide by 5 and 80 divided by 5. If you don't know your 5 times table, go to 5 12s or 60, count up. It gives you 16. So it's going to take 5 men 16 hours. So can you see why I keep mentioning common sense for these ones? Technically, the opposite's happening. If you've divided on the left, notice in this first one, on the left I divided by 4, on the right I timesed by 4. On the left I times by 5, on the right I divided by 5. Because inverse in maths quite a lot of times means the opposite. So we're doing the opposite sums on the other side if you set it out like this. And please, common sense, guys. 1 man on his own takes longer. 5 men should speed it up. So this is where we're on about reading the question is really, really important. Example 2, we're going to talk about people sharing out food now. So 4 people on a camping trip or something maybe have enough rations to last them 9 days. How long would the rations last if there were 6 people? Now, let's think of this. 4 people have got 9 food. If 2 more people come, that food's not going to last as long, is it? So bear this in mind, our answer should be less than 9. So first thing I'm going to write down is, 4 people have got food to last 9 days. It's up to you if you want to write the days or not, I'll just write it in. So food will last 4 people 9 days. 1 person on their own. So on this side I'm dividing by 4. 1 person on their own, that food would last a lot longer. So we are doing the opposite divide before we are timesing by 4 on this side. So 9 times 4 is 36. So that 1 person on their own could last a lot longer with those rations. And then we need to work out how long it would last if there's 6 people. So now we are multiplying the number of people by 6. So that means 6 people are sharing out that food. And sharing in maths means we divide. Times 6 on the left, divide by 6 on the right. And 36 divided by 6 is 6. So the food for 6 people will last 6 days. Now remember what I said at the beginning? The more people there are, the less number of days food you've got. We do have less number of people of food. So common sense, check your answer, folks. Right, question 3, bit of speed, distance, time. A train takes 7 hours for a journey, an average speed of 90 kilometres per hour. What speed must the train travel to cover the same journey in 5 hours? So they're thinking of increasing their speed. They want to do it in 5 hours. How long should it take? So the first thing we're going to write down is it's 7 hours. We can do it at a speed of 90. We need to work out, although ridiculous as it sounds, right, what speed would have to go in 1 hour, first of all. And then we need to work out what speed we need to do for 5 hours. So we're dividing our number of hours by 7. So we need to go a lot faster, don't we? If we want to decrease our time, we need to increase our speed. So we times that side by 7. 90 times 7 is 63 with a 0. I did 9 times 7 and added the 0. So to do it in 1 hour, I'd have to be going at 630 kilometres per hour. Now, I know that's impossible, but in the context of the question, it's going to help us get the next bit. So we now have 1 hour, but we want to increase that to 5 hours. So we're timesing by 5 on the left. That means we do the opposite on the other side. We divide by 5. And remember, think about it. If we're increasing our time, we are slowing down, right? For your journey to take longer, you must slow down. Remember, think of stuck in traffic. Definitely slows down your time. So we're going to have to do 630 divided by 5. I'm going to do a wee sum at the side. So we do 5 into 6 goes 1, remainder 1. 5 into 13 goes 2, remainder 3. And 5 into 30 goes 6. So that would be 126. And my speed was in kilometres per hour. So that is the speed you would need to be travelling to do it in 5 hours. Okay, so my last example is talking about some builders. So a building company predict that it would take 60 men 2 years to build a school. If the school has to be ready in 18 months, how many more men will they have to be employed? So this happens in real life. We think we need to get this job done quicker. What do we need to do? We need to increase the number of men. But the question says how many more men are they going to have to bring along? So there's a twist to this one. So the thing that goes on the left-hand side will be our number of months, our times. Now, 2 years I'm going to write is 24 months. So 24 months takes 60 men. I need to theoretically think how many men I'll need for 1 month before I'll go on and find how many men I'll need for 18 months. So what I've got here on the left is I am dividing my length of time by 24. So I need to increase my number of men by 24. So I'm doing the opposite on that side. So remember, divide on the left is a times on the right. Now, 60 times 24, possibly could do this without a calculator, but 60 times 24 is 1,440 men, right? As impossible as that sounds. We are then going to increase our time frame. So we are going from 1 to 18, so we are timesing by 18. So we divide the number of men by 18. So times on the left, divide on the right. So if you then divide that by 18, you get 80. Okay, so 24 months it took 60 men, 18 months it took 80 men. That makes sense, doesn't it? We'd wanted it in slightly less time, so we needed a wee bit more men. But the question said how many more men will we need to employ. So for this question, the answer is we started with 60, we need 80, so we need to get 20 men. So we need 20 men. I should have said 20 more men, shouldn't I? So we need 20 men extra. All right, so that's the end of my 4 examples. Hopefully you followed them. It does get a bit tricky, but honestly, go back and read the question. Think, what are they asking here? Try and think of it in common sense terms. And remember, you're basically, if you're dividing on the left, you're times on the right. You're doing the opposite from left to right today. So this is a point where you can pause and try some questions. These are all very similar to the ones I've done on my 4 examples. Unpause and check your answers. And there's your answers, and hopefully you got on okay. I put in the unitary value as well, just so you could check that when you go.
Thanks for watching. I hope this has helped.